Let's review how we take the derivative of e to the x. You probably remember that it's the easiest derivative of all to take, and that is that the derivative with respect to x of e to the x is actually e to the x. However, if e is raised to an exponent that is differentiable, something I can take the derivative of, I write it just as it was, like I did here, but I have to do the chain rule and tack on the derivative of that exponent. So it becomes e to the f of x times f prime of x, or if you want to rearrange it, f prime of x times e to the f of x. So that means when we want to reverse this derivative, we've got the integral of e to the x dx. Well, that's just going to be e to the x plus c because there's no chain rule when this exponent is just an x. However, if I have the integral of e to the f of x dx, I copy it, e to the f of x, but instead of multiplying by the derivative of f of x, I have to divide by the derivative of f of x. It's reversing the process. And of course, don't forget, with any indefinite integral, you have to write plus c. So, example 6, determine the following. The integral of 3e to the negative 0.5x dx. So I'm going to write this. First of all, let's just pull that 3 out. Integral e to the negative 0.5x dx. And of course, you don't have to do that. It just makes it a little cleaner. It's 3 times. Now remember, copy the original, but you have to divide by the derivative of that exponent, which is negative 0.5 plus c. Now we have to simplify. 3 divided by negative 0.5 is negative 6 e to the negative 0.5x plus c. Let's check it to make sure it's right. The derivative with respect to x, so we're going backwards now to see if we can get this, of negative 6 e to the negative 0.5x plus c is, remember when you have an e function, you copy the function. And since that's a differentiable exponent, I have to take the derivative of the exponent. And then, of course, the derivative of c is 0, because that's just a constant. And so I need to multiply these two constants. Negative 6 times negative 0.5 is positive 3 e to the negative 0.5x. Because plus 0, I don't need to write. And so compare that. There's the function whose derivative was taken. Here's the function we got. So we took the derivative to show that those functions match. Checking is optional. Always a great idea.